The next question is level order traversal of a binary tree. So if you are given a binary tree, what we have to do is return the nodes at each level in an array of array format, right? So suppose you have this tree, so you have to return at the first level there's only 3, then at the second level you have 9 and 2, and the third level you have 15 and 7 in this format, array of array, right? Suppose you had another node here, like to the left of 9, that would have come in front of 15. Yeah. Anyone has already done this, tried it? It's pretty much simple, not a very complicated question. I don't know why it is a medium.
Yeah, this question is a typical BFS solution, and I use a queue to put each level node to that queue, and while the queue is not empty, I iterate each level and put the node value to an array. And at the same time, I put that node left and right node to the queue. And it will iteratively traversal the whole tree and get the each level's node in to the array. Yeah, that's my solution.
Right, and what will be the time and space complexity for this one?
The time complexity is O of n is a linear because we have to iterate each node of the tree, and the time and the space complexity will be the O of n. I need the 2D array to store each node's value, so it's
let's ignore the space that is required for the result. Anything apart from
that? Except the result, we need the queue. The queue need to put each level node to that queue. Yeah. So the maximum of the queue will be the level. If the level is h, think about the last level will be the 2 to the power of h. Yeah, that's the space complexity for the maximum queue.
Right, and what will that 2 raised to power h be?
Yeah, this is an incompleted binary tree. So the last level is just 2 nodes. We are thinking of the worst cases, like there should be 4 nodes at the last level. So the size of the queue will be 4. Yeah, if the level, the root level is 0, and the first level is 1, and the last level is 2. So the number of the last level node is 2 to the power of h. H means the level. In this example, the h is 2. So the size of the last level node is 4 here. That's the worst cases if the tree is a completed tree.
Right. Let's assume we have a variation of this, but we have to return the level order traversal, but in the reverse order. Like for each level, instead of 3, 9, 20, it should be 20 and 9, and for 15 and 7, it should be 7 and 15. What will be approach in that case?
Is your question about the space complexity?
No, it's just a logic. What if we have to output? So here we are asking return level order traversal of nodes from left to right and level by level. So if the problem changes from instead of left to right, you have right to left, but level by level. What will be then?
Okay, if we need the traversal to be the right to left, we just need to put the right node first and then put the left node in the queue.
Okay, and one more variation, if
Yeah.
we want alternate. For all even number of levels, it should be left to right. For odd, it should be right to left.
Yeah, that mean in that to that question we need two stack. One is put the left first and stack put the right second, and another stack use the reverse order, put the right first and put the left second.
Do you need stacks or queues?
To that, to your question mentioned before, we need the even level is left to right. To the odd level, we need the right to left. I'll choose the stack or queue. It's almost the same. It's just control the traversal order differently for the even level and the odd level.
Can we do it in the same queue anyhow?
Two different queue or there are two different stack or two different queue. One is for the even and one is for the odd level.
And what will be the difference in both of the cases? If let's suppose for the even case, or let's suppose for the odd case, how will you process the odd ones?
The odd one is just you have the 9 and 20, and then you will get to the next level. In the next level, you store the node 15 and 7 in different order. Just revert different order from the even order. So in that stack, you have a different order, yeah, with the even order.
I was thinking if we can use the same stack, and we are at level 3. This is what we have to process, and we'll push 3 into this one, right? And at the next level, we have 9. Let's say we have to expand this. So now stack will be empty because we have popped that element. And for 3, what we'll do is we'll push its left and right child into stack. And 20, right? So for the next state, our stack will be equal to this one, right? And then 20. And we'll pop 20 first, and then 9 first.
I think it's a stack, so we have to pop the 20 first, because 20 is a, yeah. And when we pop the 20, we put the right first, then we put the 7, and then the 15.
Okay, got it. So we are saying, okay, we need 2 stacks, right? While we are processing the current stack, we can push all the results into another stack. So when you are pushing, processing 20, we can push 7 and 15 onto another stack. And once we are done with that, we can use 9 and push, suppose 1 and 8 into something else.
Yeah.
Then just replace the stack with whatever is the result, which will essentially be 1, 8, 7, 15. So intermediate, we need 1 stack to gather the results till this main stack is completely used.
If each level had the same order, the 1 stack is enough. But if you have if you want to have different order to different level, like the odd level and the even level, the order is different. So my solution is used to two stack. Yeah.
Any other ideas, guys? At least for the last variant. Sorry.
I have a question. Hey, Gaurav here. Can we solve the original problem using DFS?
Using
DFS. Instead of BFS, can we use DFS to solve this problem?
we can keep a counter and you suppose a hash map or a simple an array. We can and the maximum length of the array will be suppose n elements. We can keep it for now. We can keep n and when we are doing DFS, when we go to the next level, we can increment that counter and append the element onto the counter. You know that suppose I have a this is unique hash map. And I have, when I'm at element 3, my level is 0. So I'll append this 0 and append 3 to that. Next time I'm at 9, that's my next level will be 9. I'll have element 9 and at that time I'll have my depth suppose incremented by 1. Right? Now I have another element 1 is already there and then I'll add 1 and then add 9 to that. Right? And after that there's nothing element, I'll go back and the next element will be 20. Here also depth will be 1. Right? So after that my hash map will look something like this. And this way till all the elements are done, I'll definitely need the left to right order. So that's how DFS.
Yep. So you have to again traverse the hash map. Okay, and it's not guaranteed that keys will be in the order.
Like what I'm doing.
So instead of hash map, can we just like use an array of arrays?
Yeah, right. So I was just saying that instead of that, we can use arrays of array, but that size of the array in initials will be we have to keep n also. That length will be order of n.
Yeah.
We don't know whether it's a skewed tree or not.
No, like keep it empty. Okay, the initial array of arrays, initialize it to empty. Okay, once we start traversing the first level, okay, which is
you're saying about having a linked list kind of
yeah,
not the array of array but linked list.
yeah,
Right.
kind of like array list in Java, because
Right.
you can insert the elements. So once you are at a level, let's say 3 is at level 0, and you see at 0th index there is like no element in that array of arrays. Create an array at that index and then put 3.
Because those depths will always be in order. So level 4, if there's this level 4, level 3 will definitely exist before that.
So just like one more variant to solve this problem.
Any other approach, guys? This one is nice to have DFS also. Guys, if we don't have any other approach, we can move to the next one.